Hello, here's my video for Lab Series 2. So there's 3 separate labs in this series. There's a titration with acids and bases, there's a citric acid in drinks lab, and then an acid dissociation constant lab. So the context for these labs, they all take part in the second half of my acids and base unit. So the first lab is titrations of acids and bases. We'll do that after we discuss neutralization and how to conduct a titration. And then kind of a follow-up to that lab is the citric acid in drinks lab. So they're going to take what they learned in their original titration lab to design their own test to figure out how much citric acid is in different drinks. And then at the end of the chapter, we'll do an acid dissociation constant lab. It kind of ties together different concepts we talked about. So obviously has the acid dissociation constant, but they're also going to be doing a titration in that lab and doing some dilutions from a previous chapter. So there isn't a science standard that is specific for acids and bases, but this standard is focused on designing a solution to real-world problems. So the focus of these labs is to learn how to do a titration and then use that knowledge of the titration to learn things about the citric acids of drinks, as well as combining all the knowledge they have from the chapter in one final lab. So they're going to carry out the investigations originally to help them do the final investigation. These are the processes and skills that I want the students to learn through these 3 labs. So the content goal is just to understand the properties of acids and bases. The scientific skill goals is to be able to carry out an investigation as well as design their own investigation and then perform the calculations necessary. And then the technical skill goals is to know how to properly do a titration and to remember how to do dilutions from previous chapters. So then looking at the 3 labs, the first one is a titration with acids and bases. So in the pre-lab, they're asked to balance a reaction between sulfuric acid and sodium hydroxide. These are the same acids and bases they're going to use later in the lab. Specifically picked sulfuric acid because they won't have a 1-to-1 ratio. And I found that students tend to just assume that it's 1-to-1. So I'm trying to kind of get them out of that habit. And then they have kind of an example calculation. Again, it's very similar to the calculation they're going to have to do later to determine the unknown concentration of their acid, which looks like I need to fix this real quick so I'm doing the right acid. So then they have a purpose that they can look at, which again is just kind of a review of what we talked about the day before. Kind of what is a titration, what are we looking for, how are we going to know when we reach the equivalence point, the indicator that we're going to be using in this lab, and then kind of the color. So our objectives, they need to be able to use a burette, they need to recognize when they get to that end point of the titration, describe the procedure, and determine the molarity of the unknown. So we have our materials. Again, I forgot to change all of my acids from the original one, so I'll save you from finding some of those mistakes. Really emphasize the safety on this one since we are using unknown acids, and so wear safety goggles, gloves, lab. If anything gets in your eyes or skin, rinse it out. So then moving down into the procedure, I have a picture of the apparatus for them to set up, walks them through the steps of rinsing out their burette. This is again something we would have talked about the day before, but just kind of re-emphasizing the importance of that, and then how to perform the titration. And they'll record all that on their data sheet down here. So they're going to do the same titration 3 times. To kind of eliminate any error. We might also talk about a little bit of looking at their final answers, making sure they're all pretty similar, and maybe having to do more than 3 trials if they are really off from each other. And then give them a little area down here to figure out their unknown acid concentration. And then for the post-lab questions, I'm going to ask them what the average concentration was, so average the 3 numbers they just found, and then explain what caused any error. Specific, or be a little bit more specific than human error, so I went past the endpoint, I didn't measure things correctly in my burette, stuff like that. Kind of a side demo I'm considering doing is running a titration while they're doing theirs with our Vernier Science probes to see if I can get a nice titration curve for them to look at. If that doesn't work, I'll probably just put one on the board and then have them sketch it, and then based on that, can they figure out what the equivalence point is and the pH of the equivalence point. So then our second lab is how much citric acid is in drinks. It's kind of a follow-up to the first titration lab. They're going to take what they learned in that lab and then see if they can apply it to a real-world situation. So again, they are balancing their reaction to begin with, and again, it is not a one-to-one relationship, which is why they got this little angry comment down here to remind them to look back up these numbers. Kind of an example, which again will be very similar to what they're going to be calculating for their lab results. And then I'm just going to have them make a prediction, ranking the drinks from most citric acid to least citric acid. So now put a little bit more background on this one. Starts with, kind of the basic knowledge about titration, but then goes into some more specific instances of where titrations are used in the real world, and then specifically how we can use titrations to figure out the contents of any foods and beverages. So in this case, we're going to look at some different things that have citric acid in them, a lot of sodas. And then gives them a little background knowledge about there is citric acid and carbonic acid in pop. So we want to make sure we're using flat soda to get rid of that carbonic acid. So I gave them the different beverages that they will be testing. Gave them very little instruction in the procedure because I want them to kind of reflect back on the lab we did previously with titrations and use that to make their own. I did give them a starting amount of liquid that I wanted them to use and an amount of phenolphthalein. What I think I'm going to have them do, since we have so many different liquids, I'll probably have each group test 2 or 3 maybe, and then share the results with other groups. And then they'll make their own data table, so there isn't one on here. But their post-lab questions, go back, reflect, and rank those beverages from least to most, or most acidic to least acidic, and then to see if they actually read that background information. Why did we use flat soda to get rid of the carbonic acid? Here's just some space for them to put their data tables, some space for them to do their calculations. And then the final lab, this one occurs right at the end of the chapter, so it's going to tie in a bunch of concepts that we talked about throughout the chapter, but it's also going to introduce a new way to find the acid dissociation constant. So we have the equation that they are familiar with, and then shows how it can be rewritten with a little fraction ratio over here, which is going to be very important for this lab. So if you know the pH and you know that ratio, you can find the acid dissociation constant without using an ice table, which generally I think will make them happy because I haven't found a lot of deep lovers of the ice table. So then it just goes through an example of how they're going to do these calculations and then gives them a problem to solve on their own. So I'll give them a little, so we'll probably discuss the example together, give them a little time to do this problem on their own or maybe with their lab partner, and then we will discuss that one also, make sure they set everything up correctly. Again, it's going to be very similar to the calculations they're going to do later in the lab. So purpose is to find the pH and that ratio, and then calculate the Ka of an unknown acid, and then see if we can identify that unknown acid. So again, for our safety, we're using an unknown acid. If it gets on your eyes or skin, flush it out. So kind of a review of a lot of things we've talked about in this chapter. They're going to perform a titration. They're going to repeat that titration. And then they're going to do some calculations to get the correct ratios. So they're going to use a 1/4 ratio, a 1/2 ratio, and a 3/4 ratio. And then from that information, they'll be able to calculate the Ka. And then the end goal is that they should get 3 Kas that are very similar to each other. They'll find the average. I'll have them look up that value in the back of their book to see if they can identify the unknown acid. My plan was to use acetic acid. Some unique features of these 3 labs: I used different ratios of base to acid. So there's a 2-to-1 ratio in one lab and a 3-to-1 ratio in another. So they kind of can get into the habit of not assuming that it's always 1-to-1. It also includes some real world applications. So where do we use titrations every day in the real world? And then it gives them the opportunity to design their own lab, or at least their own lab table, to organize their information. So the reason I included these 3 labs is to introduce titrations to the students, as well as give them a chance to see the real-world applications of the different calculations that we do in the acid and base chapter. And that's all I have for my Lab Series 2 video. Thanks.